So I guess the weird news is like, I'll have proof of everything because I record notes. So if you say something didn't happen in class, I'll be like, oh, look, administrators, it did. I recorded it right here. This is the video that I take that I'll then upload to Canvas. So like our absent students, or if you have an early dismissal or something, you'll be able to pull up on Canvas in that same place and click a video link, and you'll be able to watch notes just like you were here. Just like a video of me talking. I watch lots of videos of me talking. So today we're going to take a look at number sets. I'm going to be really realistic here that a lot of teachers tell fibs, and they like make you think that the things that they teach each day are so important you're going to use them every day for the rest of your life, and that's just kind of a big fat lie. You are not going to be deciding number sets long term in your life. That's not it. However, this comes back to that same concept of if we want to be able to talk about the things that we do use, we need to have some key terms and ways to deal with them. Okay, so we're going to be talking about today how we sort of categorize numbers. And I sort of hesitate with the word categorize because it's not like we have a group over here and a group over here and a group down here. It's not like that. What we have today is a bucket. Okay, we're going to put some numbers in a bucket, and once they're in the bucket, they don't come out. So numbers can belong to multiple different sets at the same time. And the first set that we learn about at a very young age, my brain's already head from second period, are our natural numbers. And these are represented with the letter N.
I turned off.
What? I think it just went to sleep. Yep. It's still recording though. Okay, our natural numbers are anything that are just our basic counting numbers. If I handed you a certain number of blocks, could you count them? If it's a number that you could count in terms of blocks, it's a natural number. So numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4,573,652. I mean, that would be a lot of blocks to count, but we could count them. Okay, those are our natural numbers. Okay. Just so you all know, I'm sort of standing here waiting, like, and you're kind of like, oh, this is awkward. Is she waiting for me to do something? I'm just watching to make sure people are done writing. If I ever flip the page and you're still writing, just Mrs. McKinney would flip back for me. Yep, no problem. Okay. Our next set of numbers are our whole numbers. Okay, whole numbers are represented with the letter W. Now again, I'm not taking anything out of the bucket, I'm just adding to the bucket. Hi, Danny. What's up? Isaac. Yes, I do. Gotcha. Yep, we'll send him. Oh. When we're done with notes, I'm gonna send you some more, okay? Our whole numbers were then just adding to the bucket. So all the numbers that were actually there still stay there. We're just now going to include how many blocks do we have if I don't give you any?
0.
We have 0. So now our list is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So all we've done is we've added 0. So if I were to say what number sets does 1 belong to, you would tell me that 1 is a natural number and a whole number. Those are both included. However, if we're talking about 0, 0 is only a whole number at this point. Okay? Okay, so far so good? Next on our list is integers. Again, we're still adding to the bucket. Integers is represented with Z. Any ideas as to why integers is represented with Z? I don't know either. Like, I really don't know. So, over here on this sideboard over here, we'll have this Teach Mrs. McKinney. You can teach everyone in the class too. This is our extra credit list that we keep. I don't do extra credit in terms of anything else. You can do 2 of these questions per trimester. Okay, so if you decide, I want to go home and I want to figure out why an integer is represented with the letter Z, okay, you have to go home, you have to find out, and then at the start of class tomorrow, you have to tell me, whether it's 1 of you or 10 of you, and you have to report back to me in the class why an integer is represented with the letter Z. Okay? Now, here's the deal. If someone reports it tomorrow, it comes off the list. You can't decide that you then want to do that as extra credit, because we already learned it. Make sense? If nobody reports back tomorrow, then it's still up there on the list and it's still game. Roger? Got it? Okay, so integer. Integer says now we can move both directions. So what happens if you have 3 blocks and I take away 10 of them? Then we have negatives, right? So now we say we can include things like -2, -1, 0, 1, and 2, and we can continue this out both directions. The key here is that this is no fractions. No fractions, no decimals, only whole numbers being negative or positive. Okay, the next on our list is then rationals. So again, we're still just adding to the bucket. Rationals is Q. Any idea why rationals is Q? I actually know this one, so this doesn't go up on the board. Any words we've used today that starts with a Q? Quotient. How do we represent a quotient? Division. And what's a type of division sign I said we would use in algebra?
Fraction.
A fraction. Rational numbers are numbers that can be in the form A over B, where B does not equal 0. Now, this is a really textbook definition, and I'm not super big on having textbook definitions, but this is one that's kind of important. Okay, this says that it can be in the form A over B. It can be. 7 is not written as a fraction, but it's already in the bucket, which means it has to be a rational. Is there a way that I can write 7 as a fraction? Isaiah? 7 over 1. Right? So it just has to have the opportunity to be written as a fraction. It doesn't have to look like a fraction. The other piece that's key here is that B can't equal 0. This is a piece a lot of us just either sort of were taught at some point and forgot. This is really important. You cannot have a fraction with a denominator of 0. What's the word denominator mean? The bottom of a fraction. I really appreciate you like all wanting to be like good rule of followers and raising your hand, but when it's conversation like that, you can just tell me. It's fine. That's fine. Okay, because a fraction says the bottom number is how much you have and then how much you're going to share with people. If I have nothing, can I share it? No. No. Okay, no denominators of 0. Okay, so anything that can be written as a fraction is clearly it's a fraction to start with. Or a decimal, as long as that decimal either repeats. How do I write a repeating decimal? Does anybody know the symbol that we use? Brian said this thing, the bar, that repeating bar on top. That's repeating. Okay, that can be written as a fraction. You don't necessarily need to know how to do that. But my students usually agree, right? 0.3 repeating is 1/3. I'm like, oh yeah, well, I can write that as a fraction. All of the others work the same way. Okay, or it has to be a terminating decimal. What's the word terminate mean?
It stops.
It stops, right? What is the terminator about? Do we know? Am I too old?
A robot.
And what is the robot doing?
Destroying.
Right, it's the end. Everything is the end of life, or it's done. It's the end, it stops. It's a decimal that ends. 2.5. It stopped, it ended. It stopped talking. How are you doing so far? So far, so good. Then we have this weird bucket. It is weird. There's a weird bucket that falls all alone, all by its lonesome. And this weird bucket, I wrote that are weird, sorry, are our irrational numbers. I mean, our irrational numbers are weird. It is hard to fathom this concept. Irrational numbers are numbers that do not ever end, and there's no way to find a repeating pattern. Anybody know what our most famous irrational number is?
Pi.
Pi, right? Now, this is crazy to think about. There has been a computer calculating all the digits of pi, trying to see if it can find a repeating pattern. It's been doing it 24 hours a day for like 20 years. And it has never found a repeating pattern. It just keeps going. Right? I mean, that's just insane. Okay, so pi is our most common one, but there are some other weird ones. Do we know what we call this thing?
Power.
It's the opposite of a power. It's the inverse operation. Liv?
Square root.
Square root. So square roots and exponents or powers go together. We'll do a whole unit on that later. Okay, some square roots are irrational. We're going to talk about how we can check those in our calculator tomorrow when we learn more about the calculator and stuff like that. Sometimes when you put in a square root, it will give you a number like 5. The square root of 25 is 5. Well, 5 is a natural number, so that's fine. Sometimes it'll spit out a really long, messy decimal, and that is irrational. Okay, I'm writing this one in caps because if nothing else, when you take your quiz and or test, every number is in the set of real numbers. Every number that you know right now is real. Okay, this is all the rationals and all the irrationals together. If we are talking about a number, we are talking about a real number. Yes, Presley?
I just had a random question. Will you ever let us use notes on like a test? Or
Anytime
quiz?
we take a quiz, you will be able to use notes. Anytime we take a test, you will not. Okay, so if on the test or quiz it says what number set does this belong to, you better be writing down at least real. Okay, and in a couple years your teacher's gonna go, oh, but wait a minute, there's some more numbers you don't know about, and those are called imaginary numbers, and you don't have to worry about those for a while.
Wait, what's imaginary?
It's the letter I. It gets its whole separate bucket. It lives in its own world. We're not getting to that world yet. Okay, so here's how this is gonna work. Here's what we listed. You don't need to write this down now. Okay, so for a second, I'm just rewriting what we already have. What was our first number set? Natural, and then what did we add? Whole. And then what? Integer. And then what?
Rational.
Then what?
Irrational.
And we said that was kind of its own weirdo spot, right? So I'm gonna put that over here. And then what?
Real.
And we said that was everything. Our job today say is going to be to label what number set something belongs to. So, if I say 7, we want to place what number sets it belongs to. You could check with every single individual spot if you wanted to. It's going to take you more time. My suggestion is just find a starting spot, and since we know once we're in the bucket we stay, it's going to be anything underneath it as well. So, is 7 a natural number?
Yes.
Yes. So if it's a natural number, it's going to be natural, whole, integer, rational, not irrational because it's the weirdo over here,
Real.
and real. Because once we're in the bucket, we're stuck. We're in the bucket. Okay. What if I say negative 1/2?
Rational.
So let's go down the list. Is negative 1/2 natural?
No.
No, we agree with that. Is it whole?
No.
We agree with that? Is it an integer?
No. No.
This is where I get the split.
No.
What does integer introduce into the picture?
No.
Negatives. Does an integer introduce a fraction into the picture?
No.
No. So is this an integer?
No.
No. Is it rational?
Yes.
Sure is. Which means if it's rational, it's also real?
Yeah. All numbers are real.
All numbers are real. How about 6/3?
Yeah, that's real.
Is it natural?
No.
Maddie, you're nodding your head. Yes. Why? What is 6 divided by 3?
But isn't
2.
it natural? No.
We just want to simplify it. It's 2. 6/3 is 2. Is 2 a natural number?
Yeah.
Yup. So this would be that whole long list. All right. Do we get how this works? Here's what you're gonna do. In a moment, after I give you instructions, on my board on my bookshelf over here, there are board markers and erasers. If you prefer, you can use paper and pencil. I don't care. I'm just not passing you out paper. There are 16 problems around the room. You probably won't finish them all, that's fine. I'm going to assign you one number that you have to have an answer to and tell the class. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The rest of you look out for today. You'll be my starting place next time. Okay? You are going to write down what number sets they belong to if you got your own, and then you're going to keep going and do others in the room. So those of you who weren't assigned, you're not out of the activity. You're still doing them. You just don't have to tell the class. Does that make sense as to what you're doing? Any questions? Either get a board marker and eraser or get out paper or pencil and start identifying. If you've got assigned a number, you might want to start there.